In this video, we will create a graph in Kinetica with all 4 components of Kinetica's Graph API. If you haven't done so already, please go back and watch the previous videos in this series, which introduce all the 4 components and the concepts behind modeling them within Kinetica. Now let's go to Kinetica to create this graph. Right now, we are looking at the input table that we use to create the directed graph using edges and weights. Now, let's say we want to restrict the edges 2 and 5. This would require an additional column in our input table. One option here would be to go back to the source CSV file that we loaded previously and add a column there. However, this is a small table. I can also use the configure table option within Kinetica to do this. Let's add a restriction column. I will call it on_off. The data type is set to int and the initial default value is set to 1. Let's check the table out. As we can see, we have added a new column on_off. By the way, you can call this column anything you want. I've just chosen on_off for the sake of clarity. An on-off switch can take the value 0 or 1, where 0 indicates closed and 1 indicates open. Right now, all the edges are set to be open. But that's not what we want. We want edge IDs 2 and 5 to be blocked. We can do this by clicking on the edit button here to edit individual rows in this table. So let's change the value for edge ID 2 to 0. Next, let's do the same for 5. Okay, so now our input table looks good. Both the edges 2 and 5 are marked as blocked. Let's create a new graph using this table with restrictions added. The form here is pre-populated with the values from the last time we created a directed graph with weights. We can leave the previous values as is, since we are using the same input table with just an additional column. So the earlier identifiers would be mapped to the same columns in our data. We can identify each edge using its ID. So let's pick the combination for edge ID plus the on-off switch and map the columns from our input table to these identifiers. Let's also change the name so that we create a new table for this graph. Okay, now we are ready, so let's create this graph. As expected, the edge 2 has been omitted from this graph. So is the edge 5, although we can't see it yet because the edges 3 and 4 share the same WKT line. Let's check out the table to confirm that this is the case. As we can see, the edges 2 and 5 are no longer present in the graph. Now let's say we would like to block a specific node instead of an edge. This would require additional information about the nodes. So we will need a second table for nodes, in addition to the one that we've been currently using for edges. Let's import this table using the CSV importer. The table for nodes includes its location and type, which can either be a roundabout or a junction. The table also includes a node ID column. Let's use this new data to create another graph with all the 4 components specified. First, let's add the identifiers for the nodes component. Since we have an ID and a WKT point, we can use those to uniquely identify each node. Let's map the node ID and WKT point columns from the nodes table to the corresponding identifiers. Next, we need to identify the node-specific restrictions. We can do this by adding another set of identifiers to the restrictions component. Note that this is on top of the existing restrictions that we previously applied. For the restriction, we would like to block those nodes that are a roundabout. This time, instead of an on-off switch, we are going to be comparing the value of a particular field to apply restrictions based on it. In our case, we use an expression to specify whether the type column matches a roundabout to mark the nodes that need to be restricted. Let's create this graph. As expected, node 2 is no longer a part of this graph. Also notice how the edges to and from the node have been removed. Also remember that the edges 2 and 5 are still blocked since we did not remove our previous restriction when creating this graph. Let's check out the graph table to make sure that this is the case. As we can see, the only edges that are remaining in our graph are 3, 4 and 6, while the nodes 2 and edges 1, 2 and 5 have been removed. Also observe that the edge 1 was removed implicitly since node 2 was blocked. This brings us to the end of this video. To summarize, in this video we created a graph in Kinetica that used all the 4 components in Kinetica's Graph API: weights, edges, nodes and restrictions. At a bare minimum, to create a graph in Kinetica, we need to at least specify a edges component. We can add additional components like weights, nodes and restrictions on top of this to model more complex scenarios that we encounter in the real world. The key purpose when modeling data for graphs in Kinetica is to accurately identify all the different components in Kinetica's Graph API. You can do this by mapping the appropriate columns from your data to the corresponding identifiers that are provided by Kinetica.